Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you how to estimate linear and nonlinear combinations of coefficients from regression models. I'm going to be using the NHANES2L dataset, and you can open this by typing WebUse NHANES2L. You'll need an internet connection to do that. So I'm going to start off by fitting a linear regression model. So I'm going to type regress, and then BP systolic blood pressure is going to be my dependent variable, and health stat is going to be my predictor variable, and it's categorical predictor, which is why I have the I dot in front of it. So now let's say I'd like to estimate linear combinations of those coefficients. Well, I can do that by going to statistics and scrolling way down to the bottom, where it says post estimation. Okay, I'm going to move this over here, and I'm going to expand the plus next to tests, contrast, and comparison of parameter estimates. And I'm going to select linear expressions of parameter estimates. So let's move this over so I'll be able to read my output, and double click linear expressions here. And that will open the LinCom dialog box. And this allows me to specify linear combinations of those coefficients. So if you're not familiar with doing this, we can click create, and that'll sort of walk us through this process. So I can select or expand the box next to where it says coefficients. And I can either select coefficients or their standard errors. So I'm going to select coefficients here. And maybe I would like to estimate the expected systolic blood pressure for someone in the poor health status. So that's category 5. So I just happen to know that. Excellent is the category 1. It's the referent category. Very good is 2. Good is 3. Fair is 4. And poor is 5. So let's first select the constant. So that's going to be the intercept. And then I'm going to type plus, which is over here. And then I want to add the 5 dot health status. That's the coefficient for the poor category. So if I select OK and submit, what that will then do is estimate the linear combination of the intercept or underscore cons plus the coefficient for health stat, which is 16.4. And the test that it's testing is that that's equal to 0. So that's what this p-value, t-statistic and p-value is for. But what it's actually estimating, this coefficient here, is that linear combination of coefficients, which in this case would be the expected systolic blood pressure for someone in category 5, in poor health category. Okay. So I might want to just test whether or not category 5 is equal to 0, or what is that category. So I could just specify B5 and click submit, and it will show me 16.42, which is that coefficient right there. I can also estimate the difference between two coefficients. So maybe I like to subtract the fair category coefficient from the poor category coefficient. So I can come back here and click create and select minus, and then go back to coefficients, and then select category 4 for health stat. So now it's going to be B5 minus B4, and click OK and submit. And now the command is going to be LinCom, and then we have underscore B with 5 health stat in square brackets minus underscore B 4 dot health status. So that's the poor category versus the very, that's, what is it again? Poor versus fair. Okay. So that's what LinCom is doing, is subtracting the difference between those. So the difference between them is 1.7. Well, we could have done that with a calculator, but this gives us a standard error, a t-statistic, and a p-value testing that that difference, or the sum of the negative of the first one, is equal to 0. And it gives us a confidence interval for that difference. Okay. So that's another thing you can do with LinCom. So let's cancel that and then take a look at right below linear expressions. There's another box that says, or an option that says nonlinear expressions of parameter estimates. Let's double click that. And same idea, I can click create. And for nonlinear expression, let's click create again, and then go under coefficients and select coefficients. Now maybe I'd like to see the ratio of two of these. So let's do the ratio of category 5 of health status divided by category 4. Okay, that's nonlinear because it's a ratio of the two. So if we click OK, OK again, and click submit, that will issue the command nlcom, and then it will again use underscore B with the 5 health stat, the 5 dot health stat in square brackets, divided by underscore B, and then 4.healthstat in the square brackets. So again, what it's doing is estimating the ratio of those two. And so it gives us the coefficient, the standard error, z-statistic, and p-value. Testing, I believe it's testing that the null hypothesis that ratio equals 1, because that would be the null in this case. And then we also get a confidence interval for that. Okay? So those are some of the ways that you can estimate linear and nonlinear expressions of coefficients after you fit a model. I hope this was helpful. Thanks for stopping by.